In this video, we will solve a problem on driven RL circuit. So circuit is given here. In this, you have to determine an expression for IR of t. So a 10 milliampere current source is given, and at a t equal to 0, switch will be opened. Before that, switch is closed. At a t equal to 0, switch will be opened. And you have 0.1 Henry inductor and two resistors, 60 ohm and 40 ohm. And current passing through this 60 ohm resistor is IR. So you have to determine expression for this IR. Okay. So we will first write for t less than 0. What is the equivalent circuit? T less than 0, this switch is closed. So all the current flows through this short circuit. Short circuit means like this current, all the current will flow. So this part of the circuit will not receive any current because there is a short circuit. All 10 milliampere current will pass through this one because this switch will be open only after t equal to 0. So before that switch is closed and 10 ampere current flows through like this. So all current here, all current will flow through like this. So no current, I can separate this part, no current flows through this. So here in this one, this IR is absolutely 0. And what about IL? This also 0. IL, this also 0. Okay. So we can write this one at this moment. What is IR of 0 minus? No current. IL of 0 minus no current. All the current flows through like this. For t greater than 0, for t greater than 0, what is the circuit? Switch will be opened. So switch will be opened means this branch will not be there. So this directly goes like this, and you have (60 ohm and 40 ohm and 0.1 Henry), and current flowing through this is IR, and this current is 10 milliampere. Okay, so this one, this is IR at t greater than 0. Okay, now we will solve this one. Step 1. The question is determine an expression for IR of t. So step 1 will be, we will first calculate IR of 0 minus. Again, to find IR of 0 plus, we do not need IR of 0 minus. That is for inductor. To calculate IL of 0 plus, you need IL of 0 minus. For resistor, we don't need, but still we will calculate all the values. Okay, we don't need IR 0 minus to calculate IR 0 plus. Okay, anyway, we will calculate this value. So IR of 0 minus, directly we can write it is 0 ampere. So no current flows through. And we will write IL of 0 minus also because this is required to write IL of 0 plus. So that also 0 ampere because of this short circuit. No current flows through the resistor also, inductor. What is IL of 0 plus then? IL of 0 plus will be 0 ampere itself because it is nothing but IL of 0 minus. So what we have to calculate now? IR of 0 plus. The moment switch is opened, what is the current flowing through this 60 ohm? So what happens here, the moment switch is open, the before switch is open, no current is flowing through inductor. So as soon as switch is opened, this state of the current flowing through this continues. What is the state? No current is flowing through inductor at IR of 0, at t equal to 0 minus. So at t equal to 0 plus also, no current flows through the inductor. But you are pumping 10 ampere current, 10 milliampere current. Inductor is not ready to allow any current at moment t equal to 0 plus. So who has to allow? 60 ohm resistance has to allow complete current. So it will take the complete current. So IR of 0 plus is nothing but 10 milliampere. This is happening because inductor resists abrupt change. No current was flowing, all of a sudden you try to pump 10 milliampere, it will not allow. So 60 ohm resistor has to take all the current. But as time passes, current will pass through the inductor because it resists only abrupt change. After that it will slowly allow. So once it slowly allows the current, finally what happens, this will act like an inductor. So it will be like a two branches, 60 ohm and 40 ohm resistor, and current flowing through this branch will be can be calculated using current divider formula. Okay, so first in the step 1 we will just calculate IR of 0 minus, IR of 0 plus, and IL of 0 minus and IL of 0 plus. Okay, step 2 we have to calculate now tau. So tau is in this case L divided by R equivalent. So we have to calculate now R equivalent because we have two resistors. What is the procedure for finding R equivalent? First, deactivate the independent source. How to deactivate current source? Make it open. So next one, this resistance and this resistance that is appearing across this inductor. So equivalent, R equivalent is nothing but the resistance seen by the inductance when the independent sources are deactivated. So here what is the R equivalent? R equivalent is 60 plus 40, that is 100 ohm. 100 ohm. So tau is L is given 0.1 Henry by 100. So it will be 1 millisecond. So it will be 1 millisecond. That is step 2. Step 3, you have to calculate final current, IRF we have to calculate, because finally we need an expression for IR. Since this circuit has an inductance current, or current through all the elements will have the form of IRF plus IRN. So any current you want to determine, that will have the form of force response plus natural response. So IL of t you want to calculate, it will be ILN plus ILF. If you want to calculate IR of t, then it is IRN plus IRF, where IRN denotes natural response of the current and IRF represents force response of the current. Okay, so IRF required, or we can even call this one as IR infinity or steady state IR current. So what is the steady state current? Finally what happens, initially inductor didn't allow any current, so all the current were flowing through this 60 ohm, but at time passes this allows, so finally this act like a short. So if it act like a short, then it has two branches, 60 ohm, 40 ohm, and current passing through this 60 ohm is can be calculated using current divider formula. So that is total current, that is 10 milliampere, current resistance of other branch, that is 40, divided by total resistance, that is 60 plus 40. So it is 400 milli divided by 100. So this will be 4 milli. So initial current passing through the resistance was 10 milliampere, but at t equal to infinity, or when t is very much greater than 0, so that time what happens, your current passing through the resistance will be finally 4 milliampere. Okay, so step 4 is nothing but the complete response. It's a driven RL circuit. So IR of t we have to calculate, it is IRN plus IRF, where IRN is a natural response. What is the natural response? That also we know. Natural response will take this form, A into 1 constant into exponent minus t by tau. Tau value we have calculated 1 millisecond, plus IRF we just now calculated, that is 4 milli. So this will be A e power minus t by tau is 1 milli plus 4 milli. Now we have to find this constant A. So for that we need initial condition, that is IR of 0 plus we need IR of 0 plus. If you are calculating for inductance, you need IL of 0 plus. But here we are calculating current passing through resistance, so we need IR of 0 plus. So IR of 0 plus, that is nothing but we calculated before, that is 10 milliampere, 10 milliampere, 10 milliampere, 10 milliampere plus 10 milliampere equal to, and A t equal to 0, you have to substitute, that will be 0 plus 4m. Okay, so this A, e power 0 is 1, so A is nothing but 10 minus 4, that is 6m. So you will get A equal to 6m. So A equal to 6m. Now if you substitute in the main equation IR of t, that will be equal to natural response, that is 6 milli into e power minus t by 1 milli plus 4 milli. Now you can substitute here t equal to 0. So what happens t equal to 0? What current we are expecting? T equal to 0, we are expecting a current of 10 milliamp. You substitute t equal to 0 here. So e power 0, that will be 1. 6m plus 4m, that is nothing but a 10m. But as t increases, this term will dominate and this 6m will become finally 0, because as t increases, the decay rate will be more, and this term will be 0 and only 4 milliampere will get. So IR final value is this 4 milli, but initial value will be 6m plus 4m, 10m. Okay, that's it.